Now say the new concept is the center of mass. See here, by using this concept or by using this center of mass, we can replace the system of the particles by a single point, equivalent single point, and that point is referred as center of mass. So, center of mass of a body or a system is defined as a point where entire mass of the body or the system is assumed to be concentrated. So, here suppose you have got like this system I am taking, this is x axis and this is y axis, this is the origin. Suppose one mass is one point mass is here whose mass is m1 and it is lying at a distance x1 from the origin. There is another mass of m2 which is at a distance of x2 from the origin. So, this system, here it is a system of the two bodies m1 and m2. I have chosen an origin, that is the point O. We have chosen a frame, that is the frame of reference here. So, we can define the center of mass x, COM. X is representing here the position of the center of mass. We can write here m1 x1 plus m2 x2 divided by m1 plus m2. So, by using this formula we can calculate center of mass. Suppose you are taking m1 is equal to, if you are taking m1 is equal to m2 is equal to m, then what will happen? We can write here xcom, that is here xcom is equal to, that will get cancelled here, you will be getting x1 plus x2 divided by 2. If these two bodies are having the same mass, then their center of mass is lying actually exactly midway, and that can be calculated by this formula. Now, we have discussed the system of the two particles. If the system has n number of particles, then we can write here m1 x1 plus m2 x2 plus mn xn divided by m1 plus m2 plus mn. Here we can also write here summation, this is a sum of all these. We can write here mi xi, this is I is equal to 1 to n divided by here mi, and here this mi can be written here capital M, that is the total mass. So, we can write here xcom, that is the position of center of mass in x axis, that is equal to here mi xi divided by this m, that is I is equal to 1 to n. So, this can be used for calculating the position of the center of mass when the system has n number of particles. Suppose you have a system of the 3 particles, obviously they are not in the one axis along x line, x axis, they are in the xy plane. So, suppose m1 has got particle coordinate is here x1 and y1, m2 mass has got the coordinate x2 and y2, and m3 has got the coordinate here suppose x3 and y3. If you want to calculate the center of mass of this system of these 3 masses, we can calculate first x, that is here m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Similarly, we can calculate y, because the center of mass which have, it has got the 2 coordinates x and y. So, we can write m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So, by this way we can calculate the position of the center of mass if the particles are lying in the xy plane. If Ri is the suppose position of the ith particle, then you can write Ri is equal to xi cap plus yj cap plus zk cap. Now, R capital R, this one is the position vector of the center of mass. Then you can write here xi cap plus yj cap plus zk cap. In that case, you can write here R is equal to sigma I is equal to 1 to n MIRI divided by capital M. So, all these center of mass can be written in terms of x axis, y axis as well as z axis as it is required or as per the given question. So, now we have done the center of mass and position of the center of mass. Suppose you are writing expression for the position of center of mass, we can write M1 R1 plus M2 R2 plus Mn Rn divided by M1 plus M2 plus Mn. Now, if you want to calculate velocity of the position of velocity of the center of mass, differentiate it, you will be getting here dr upon dt is equal to m1 v1 plus m2 v2 plus mn vn divided by m1 plus m2 plus mn. Now, if you want to calculate acceleration, so you can also write that is equal to dv upon dt is equal to, I have differentiated velocity again, you will be getting m1 a1 plus m2 a2 plus mn an divided by m1 plus m2 plus mn. So, by using these concepts, we can attempt questions or we can solve the questions related to the position of the center of mass, velocities of the center of mass and also acceleration of the center of mass. Now, see here in the center of mass we have done like a formula here, R is equal to M1 R1 plus M2 R2. So, we are getting the position of the each particle and M1 R1 and then M2 R2 and then we are adding. So, if you take the rigid body and is made of the large number of the particles and the distances between the particles is so small, so it is very difficult or it is impossible to take the individual particles and then get the summation. In that case, we can consider the body of the continuous distribution of mass. So, if you have got a large body or any body is there and that can be considered uniform distribution of the mass, that is the continuous distribution of the mass. In that case, you can apply the concept for the position of center of mass, R is equal to 1 upon m, we can integrate R dm. So, what happened? Suppose you have taken here a scale like this, it can be considered as a continuous distribution of mass. So, first we consider then a small element here of the delta m small mass and then we keep on adding. So, we do here integration process and for the different coordinates we can solve by using this formula. So, if the body has got the continuous distribution of mass, then we can apply this concept to calculate the position of the center of mass. Now, see in this example, there are 4 masses m, 2m, 3m and 4m. All these masses are placed at the 4 corners of a square having side A. Now, you have to locate position of the center of mass. For the calculation of center of mass, first we assume origin. Suppose this point we take as origin, that is O. This we can take as x axis and this we can take as y axis. So, this figure is in the xy plane. Now, we write coordinates of all these particles. Its coordinates are suppose 0 and 0. Its coordinates are a and 0 because x coordinate is a and y is 0. Its coordinate is here a and its coordinate is also here 0 and a. So, we have got this. Now, this is in xy plane. So, obviously, the position of the center of mass will have both the coordinates x and y. So, let us calculate first x coordinate. So, x coordinate we can calculate here m1, this can be considered m into 0 plus 2m into a plus 3m into a plus 4m into 0 divided by here m plus 2m plus 3m plus 4m. So, this part is 0, this term is 0. So, 3 to 5, this is a 5m a divided by 10m. So, this cancel and this cancel, so that is here a by 2. So, x coordinate of the center of mass of this system is a by 2. Now, similarly we can calculate y coordinate. So, if you are calculating y coordinate, so we can write here y is equal to m into 0 plus 2m into 0 because its y coordinate is also 0 plus 3m into 0 a plus 4m into a divided by 10m. If you add all these m plus 2m plus 3m plus 4m, then you will be getting here 7m a by 10m. This is cancel here. So, 7a by 10. So, coordinates of the center of mass of this is here a by 2, that is the x coordinate, and 7a by 10 is the y coordinates. So, by this way you can calculate the position of the center of mass.